All right, so today we're going to talk about ionic bonding and drawing Lewis dot diagrams or dot diagrams. So the first thing you need to know about ionic bonding is that it's the electrostatic attraction between cations and anions.
Okay.
We'll explain that in a minute.
Good.
So more or less what you need to know, ionic bonds occur between metals and nonmetals.
Okay.
Big punchline to take home. Ionic bonds transfer electrons. They're transferred from the metal to the nonmetal.
So we're actually taking
and giving.
So maybe when we talked about the oxidation numbers, and we say that the metals are losing those electrons, is that where they're going?
Exactly, to the nonmetals. Good job, man.
Thank you.
All right, so what we need to focus on here, just real quick, is understand that the metals lose the electrons, and when you lose an electron, you become more positive because you're losing negative charges, and we call that a cation. Did y'all talk about that already?
No.
No. Okay, so this is new vocabulary. A cation. So we've got a positively charged ion is a cation. Now, metals lose the electrons, they form cations. Non-metals gain electrons.
All right, and they're the dog ions.
Yeah, you're close. It's an anion. Okay, so we have cations are positive, anions are negatively charged ions. Anions gain electrons, cations lose them. Now, I do have a way to help you remember a cation's positive, anion's negative. So we look at the word cation, not cation, cation, and then we have an anion. Now, the way that I remember that a cation is positive is that, to me, that looks like a little plus sign in the word.
That's clever.
Okay, so cations are positive. Now, for the anion, it's just, you have to know that it's a negative ion. And that's now, some characteristics of ionic compounds. First and foremost, once you lose and you gain these negative charges, they're going to be equal to each other. So the overall charge of an ionic compound is going to be
Zero.
Yeah, or
Okay,
neutral. Cool. We can say either one. So that means our total of our negative charges are equal to the total of our positive charges. Now, we can call ionic compounds salts. So if you hear something being called a salt, you know that that can be used interchangeably for an ionic compound. We can also call them, the actual chemical formula, a formula unit. So if you hear the formula unit, you know that they're talking about an ionic compound specifically, not covalent, which you will learn about in a little bit. All right, so to talk about some quick properties of ionic compounds before we learn how to draw the Lewis dot structures for them. First, that ionic compounds are made up of a metal and a nonmetal. We already hit that high point. They are solid, crystalline structure. They have a high melting point. They're soluble in water. They're hard or brittle. That means that they're not malleable. You can't beat them into thin sheets.
So if I hit one, it's going to break.
Yeah, exactly. And awesome thing about ionic compounds, because they have that plus and that minus in there, that they conduct electricity. But the only kicker is they have to be dissolved or they have to be melted. They only conduct if they're dissolved or melted. They will not conduct electricity if they're solid.
Okay.